Okay, guys, so look like no one is attending the discussion. So in that case, I will talk about the stiocheometry. Okay, so let's remove the camera, go to the whiteboard. Okay, today I will talk about the stiocheometry because no one attended the discussion to ask some question about what we have the reaction. The stiocheometry okay, if you need to see this video before, before using see this video, go and review the slides about talking about the stiocheometry. Stiocheometry, it is the measurement in chemistry. As I said, review the PowerPoint slides before seeing this video, which we will practice with some example about the mole, what is the mole, how we will do the calculation for the mole, and later for the stiocheometry. First of all, we need to know what is the mole. Mole mean two things. First, mean number. Second, mean mass. So two things, either number or mass. 1 mole of anything of X, anything, will equal Avogadro's number. What is the Avogadro's number? It is 6.02 times 10 to power 23 of X. 1 mole of anything mean a number, but that number, it is Avogadro's number, which is 6.02 times 10 to power 23. Now, mole also mean mass. 1 mole of X will equal mass of X in a gram unit. In a gram unit. X could be atom, could be molecule, could be ion. Now, let's look here, for example. 1 mole of carbon will equal, we said the mole mean two things. If it's a number, will give us this number, 6.022 times 10 to power 23 carbon atom. So here our X, it is the carbon atom. We said 1 mole could mean mass. So 1 mole of carbon will equal mass. What is the mass? It is the mass of X. Our X here, it is carbon. So the mass of carbon in a gram unit, what is it? Here, the mass of X will equal the either the atomic weight or molecular weight if we have molecule. So we'll equal the atomic weight if we have atom, will equal the molecular weight if we have molecule, compound. So here we just have atom, so we'll equal the atomic weight. What is the atomic weight for carbon? Equal to 12, but in a gram unit, 12 a gram. So here we have 1 mole of carbon equal a number equal 6.02 times 10 to power 23 carbon atom, or 1 mole of carbon will equal 12 gram, which is the atomic weight. Let's do the same things for oxygen, for example. 1 mole of oxygen will give us a number. will give us 6.022 times 10 to power 23 oxygen atom. Now, if we need the meaning mass for the mole, so 1 mole of oxygen will equal the atomic weight of oxygen because it's just atom, so it will be 16, but in a gram unit, so it will equal 16 a gram. Now, what about if we have a molecule? Let's say here we have 1 mole H2O, water molecule. Of course, will give us a number, 6.022 times 10 to power 23 H2O molecule. Also, 1 mole water could equal mass. Now, the mass for the molecule, molecular weight, what it is the summation of the total atomic weight of all the elements in that molecule. So here we have 2 hydrogen, so it will be 2 times 1 for each hydrogen because the atomic weight for the hydrogen 1, plus 1 oxygen, so it will be 1 times 16 for the oxygen. The total will give you 18. So this is the 18 atomic mass unit for the molecular weight of water, but we said in a mole will be gram. So 1 mole of water will equal 18 a gram. Let's go with some more example about the mole. And guys, this is very important. The mole, you have to understand how you will deal with it. You will see, like we will practice later with some example about the mole. And as I said, it is very, very important. Okay. Now, first of all, the molecular weight. What is the molecular weight, for example, for NaCl? Molecular weight. Sometimes later we will call it molar mass, which has the symbol capital M, capital M. Molecular weight, molecular formula weight, sorry, molar mass, all these represent the mass of the molecule. NaCl, we have 1 sodium, so it will be 1 times 23, which is the atomic weight for sodium, plus 1 times 35.5, which is the atomic weight for the chlorine. Do the math, it will give you 58.5 is the molecular weight for the sodium chloride. Okay, let's go again for the mole. And let's practice with some example. We said mole equal 2 things. Could equal number, which is 6.02, here 1 mole, times 10 to power 23 x, 1 mole, x equal 6.02 times 10 to power 23 x. Mole could equal mass, we said. 1 mole x will equal mass of x in a gram. X could be atom, could be molecule, could be ion. Okay? Now, these 2 meaning, we will use it as conversion factor. Conversion factors. What does that mean? As a factor, we can say, we can write it down as a numerator denominator. We can say 1 mole of x divided by 6.02 times 10 to power 23. And this, we can flip it, we can say 6.02 times 10 to power 23 x give us 1 mole. So it could be as a conversion factor. Also, the mass, we can do it like 1 mole of x divided by mass x in a gram unit. Here, mass x in a gram unit 1 mole X. Now, when you will do the calculation for mole, either they will ask you what is the mole or the mass. You need to know, or sometimes they are asking about the numbers of atom or molecule. You need to use either one of these factors or maybe both of them sometimes, depending on the information on the question. Remember, always mole equal either a number, which is 6.02 times 10 to the power 23, or equal a mass, which is the mass in a gram of X. It could be atom, could be ion, could be molecule. If it's molecule, it will be the summation of all the atomic weight of the atoms that we have in the chemical formula of the molecule. Look to this example. How many gram? So, how many gram in 0.5 mole H2O? Okay. Always remember what we learned in the dimensional analysis. We have given information times a factor. That factor, we need to write it down as a numerator denominator. Which one will go to the top? Which one will go to the bottom? Always go to the top. It is the wanted, what they are asking. And in the bottom, it is the given. To cancel the given with the given, and we will end up with the wanted. Sometimes we have to use one factor. Sometimes we have to use more than one factor. But always start with the given information. I have 0.5 mole. Put 0.5 mole H2O. And of course, times the factor. They are asking how many grams. They are asking for the mass of H2O. Now you have to think which one you will use. Will you use the meaning 1 factor or meaning 2 factor? The number or the mass? Look, the information in the question. They give you more and they are asking for the mass. So which one you will use? Of course, I will use the factor 2 here, which is 1 more, give me mass. They didn't ask for the number. If they ask for the number, I will use number 1. But here they are asking for the mass. So here you will use this factor. Now, this factor, we said it will be either 1 mole of X, our X here is a water, divided by mass of water, or mass of water divided by 1 mole. Always look for this formula. Remember this formula of dimensional analysis. Given times the wanted in the top, the given in the bottom. Okay, so I will use this this factor in 2, but which one will go to the top? With the mass of water in a gram will be in the top, and 1 mole of water will be in the bottom, to cancel mole of water with mole of water here. Now, what is the mass of water? It is the molecular weight. What is the molecular weight of water? It is the summation of the atomic weight of all the elements that we have it in the chemical formula. So here we have H2O, so 2 times 1 for the hydrogen plus 1 times 16 for the oxygen, give us 18. So here I will have 18 grams. So it will be 0.5 mole H2O times 18 gram for the water divided by 1 mole H2O. Cancel mole H2O with a mole H2O. Do the math. 0.5 times 8 will give us 9 grams. So this is the mass of the water in 0.5 mole. So guys, be careful like how you will deal with this question. Always start with the given information. And of course, times either 1 factor or sometimes 2 factor. And look which factor you will use it. And always look to, and remember these formula. We need to cancel. If you cannot be able to cancel, you have to flip maybe your factor. So always check about these. Now, one more thing. This meaning here, the mole meaning in mass, we call it the molar mass. Molar mass. And it has the symbol capital M, capital M. Okay, now let's keep going and practice with some other example. Okay, it looks like we still don't have anyone in the discussion. If anyone can want to enter, they can leave it open. So let's keep practice with more example about the mole. Okay, now let's talk again about. Sorry, let's practice it with another question about the mole. Okay, how many? Let's say how many. Uh, how many? Let's keep it water. How many H2O molecule we have in zero point 0.5 mole H2O. So look at here, the same number of moles. But the first question they were asking about mass. Right now they are asking about how many molecule of water. Always start with the given information, zero point 0.5 mole H2O. And of course, we'll multiply by a factor. Now, which factor you will use? Remember, mole mean two things, either a number or a mass. So here, mole either mean a number, which is Avogadro's number, 6.02 times 10 to the power 23, or mole mean mass, which is the molar mass. Here, you have to know which factor you will use. So look at here. To look to the information in your question, they give you mole and they are asking for molecule, for number. So of course, I will use this one. Now, which one will go to the top? Which one go to the bottom? This is very important. This is the step that you will do to solve these problems. So always the given times the wanted in the top, given in the bottom. Dimensional analysis formula. Okay, so here I will put the 1 mole H2O in the bottom, and in the top I will put the number 6.02 times 10 to the power 23, which we call it Avogadro's number. This number, we call it Avogadro's number, H2O molecule. Now, cancel mole H2O with mole H2O. Do the math. 0.5 times this number here will give us here approximately 3.01 times 10 to the power 23 H2O molecule. Guys, always check the number after me because I'm not using the calculator right now. Okay, let's keep going and practice with another example. Let's say we have, okay, what is our, how many, sorry, H2O molecule we have in 36 gram water. So look at here, this question, they are asking the number of molecule of water in a mass, not in a mole. The first one was in a mole. But always we will start with the given information, 36 gram H2O. Now, of course, times the factor. Could be one factor, could be two factor. Guys, be careful. So which one you will use? If you will use the number one, which give you the relationship between mole and number, do you think it will help us to do that? Look at here. Do we have a mole? No. Now, what about if we will use the second one, mole and mass? We have a mass, but not mole. They asking for the molecule. When you have a situation, they give you information about mass and they are asking for number, or the vice versa. They give you number and they are asking for mass. You have to use both factors, both of them. And we have to know how to write down these factors. So look at here, we need to cancel. So first of all, we need to get rid of the gram. So I will use the second factor first here. So I will put the mass here, which is the mass of water, the molar mass, it is 18 gram H2O, and in the top 1 mole H2O. To cancel the gram of water with gram of water. Okay, now later I need to get rid of the mole of water. So how you will write down this factor right now? So I will put the 1 mole H2O in the bottom, and the number 6.02 times 10 to power 23 H2O molecule in the top. To cancel mole H2O with mole H2O. Now I'm fine. I just need to do the math. 36 divided by 18 give you 2 times the 6.02 will give you 1.2 approximately times 10 to power 24 H2O molecule. Guys, also check the number. I'm not using the calculator to just go quickly. So just always check the numbers in your calculator. Okay, so this is how we will deal with this type of question. If you let's practice with one more example here quickly before starting with the multimole ratio. Let's say, okay, how many moles of let's say CO2 in 80 gram in 80 gram CO2. Okay, start with the given information, 80 gram CO2 times a factor. Which factor you will use? Could be one, could be two of them. Look what they are asking. They give you mass, they are asking for mole. Which factor it has the relationship between mole and a mass? It is the second one here. It is this one. So here I will use just one factor. The two factor we will use it when we have in the question number and mass. Maybe they give you mass and ask about number. Maybe they give you number and ask about the mass. In that case, we need to use both factors. If give you mole and mass, we will use the second meaning. Give you mole and number, so that we will use the factor one. So let's keep going with that question. So we will use the molar mass, which is the second factor here. Which one will go to the top? It will be the mole, 1 mole CO2. And in the bottom, it is the molar mass of CO2. What is the molar mass of CO2? Carbon 12, 2 times 16 for the oxygen, give us 44 gram CO2. Cancel gram CO2 for the gram CO2. 88 divided by 44 give us 2 more CO2. And this is the answer for this question. Okay. Next, we will talk about the stiocheometry and the multimole ratio in our calculation. Also, don't forget, before look at this video, go and see the PowerPoint slides, get some idea. Okay. Okay. Now for the multimole ratio. Look at here. Excuse me. Let's say we have hydrogen gas plus oxygen gas give us H2O liquid. Let's balance it. Here we need 2 H2O and 2 H2. Guys, always check the balancing the equation, because it's your responsibility to be sure that the equation is balanced or not before starting with your calculation. If the equation not balanced, it will give you error in your calculation. So always check the equation. Is it balanced or not? Okay. Now, we have this number, which is the coefficient number. This coefficient number, it gives us the relationship between the chemical in the measurement. This number could be either considered as a molecule or mole. In our calculation, we will use it as uh, a mole, but it's fine. We can use it also in our calculation as a molecule. There is no problem. So here I can say 2 mole H2 will react with 2 mole, with 1 mole O2, give me 2 mole H2O. Now this number we can write it down as a mole to mole ratio. So for example, if we are looking to the mole to mole ratio between oxygen O2 and H2, what is the mole to mole ratio? You will get it from the from the coefficient number in the balanced chemical equation. Look at here. What do you have? I have 1, so it will be 1 mole O2. What about H2? I get it from the balanced chemical equation, so it will be 2 mole H2. So this represents the mole to mole ratio between O2 and H2. These we will use it later as a factor, as a conversion factor, and there is no problem if you flip it. So I can say 2 mole H2 for every 1 mole O2. The same things with, for example, the water H2O and oxygen O2. What is the mole to mole ratio? Get it from the coefficient number in the balanced chemical equation. I have 2 here, so you will put 2 mole H2O. Oxygen, I have 1, so it will be 1 mole O2. And also I can flip it. I can say 1 mole O2 divided by 2 mole H2O. If we are asking for the mole to mole ratio between H2O and the hydrogen, H2, I also will get it from the coefficient number. Here I have 2 mole H2O. Hydrogen, it is 2 mole. You don't need to simplify it. If you will simplify it, it will give you the same thing. So if you will make it 1 mole H2O, 1 mole H2, after you simplify it, it will be fine. But keep the number the same, will not affect. So I can write it down as 2 mole H2 divided by 2 mole H2O. Okay. As I said, this we call it mole to mole ratio. Mole to mole ratio. So when you are asking what is the mole to mole ratio between O2 and H2, it is this one or this one, doesn't matter. Okay. Now we will use this mole to mole ratio in our calculation for the stiocheometry. So for example, in this equation, let's practice quickly with one quick example here. If we ask how many mole of O2 will produce, how many mole of H2O, let's replace it to H2O, will produce if we use 2 mole O2. 2 mole O2. How many mole of H2O will produce? Always start with the given information. What they give you? Give you 2 mole O2. And of course, times the factor. Which factor you will use here? You will look to the mole to mole ratio, the relationship between O2 and H2O. What is the mole to mole ratio between O2 and H2O? Go back to the equation and look to the coefficient number for O2 and H2O. These represent the mole to mole ratio. Now it's very important to know which one will go to the top, which one will go to the bottom. So here, in that situation, I will put the 1 mole O2, which I get it from the balanced chemical equation here, in the bottom to cancel it with the mole. I need to cancel it, okay? And in the top, I will put the 2 mole H2O, which I also get it from the balanced chemical equation, coefficient number. Now, do the math after you cancel the mole O2 with mole O2. 2 times 2 gives me 4 mole H2O. And this is the answer. How many mole of H2O will it produce? If we use 2 mole of O2, will be just 4 mole H2O. Now be careful, guys. Sometimes the students confusing which one ratio you will use. Go and look for your information in the question. Uh, uh, they give you O2, they are asking for H2O. So I don't care about H2. Just focus in the number for O2 and H2O. That's how you will get the mole ratio. Another thing, sometimes in the question, they give some information about the third chemical. Like, for example, here with axis H2. Anytime when you will see this axis of any chemical, don't worry about it. Ignore it. Imagine that it doesn't exist in your equation. Don't let this confuse you. Okay, now let's keep a practice with some other example. Actually, before practice, I just want to give you a map how to deal with these type of equation in the stiocheometry. And just keep also this map always in front of you when you will do this calculation in your online homework or the quiz or or in the exam. Look here, guys. There is a map. You can use it to solve this type of equation. We have in the question always two chemicals, X and Y. Look at here. Let's say, for example, chemical X give me chemical Y. So always they give you information about, for example, X, and they asking for some information for Y. Now, remember we have mole X, and here let's say mole Y. How you will go from mole X to mole Y? The same things what we did in the previous example, using mole to mole ratio between X and Y. What is the mole to mole ratio? You can use it from the coefficient number of X and Y in the balanced chemical equation. Now, sometimes they give you mass of X. Mass of X. What you're going to do in this situation? First of all, you need to convert the mass of X to mole of X. How you will convert the mass of X to mole of X? Using molar mass of X. Remember, mole mean two things. Could be either number or mass. So here will be equal mass of X milligram unit. Okay, sometimes they give you mass of X or mole of X, and they are asking for mass of Y. Mass of Y. What you're going to do? You will do the same thing. You will convert the mole of Y to mass of Y by using here molar mass of Y. So here, you have to know where you will start and where you have to end. Let's do this. Step 1. This is step 2, step 3, step 4. If they give you 1 and you need to go to 2, you will use the molar mass of X as a factor. If they give it to you, for example, if you want to go from 2 to 3, you will use the mole to mole ratio between X and Y. If you want to go from 3 to 4, you will use the molar mass of Y. So using this map, it will help you a lot. Let's practice with this example. Let's keep the question, the previous example, H2, 2H2 plus O2 gas, give me H2O liquid, and here we have 2 coefficient numbers. Okay, let's say, for example, we have this equation. What is the mass of O2 required to react with 2 mole H2. Look at here. First of all, we have 2 mole H2, and they are asking for mass O2. Now, the given information, it will be either step 1 or step 2. X, it is the given. Y, it is the wanted. Remember, always we have two chemicals, X and Y. So they give you 2 mole H2. So you need to know where you are in step 2 or step 1. I have 2 mole, so I'm in step 2. Now, you need to go where you have to go, to 3 or 4. The wanted, it is a 3 or 4. So the given 1 and 2, the wanted 3 and 4. So here, they give me 2 mole, so I'm in step 2. Now, I want to see, like, where should I go, to 3 or 4? They are asking for mass, so I have to go to 4. Now, how you will go from 2 to 3? Start with a 2 to 3. Start with the given information, 2 mole H2 times a factor. Which factor you will use to go from 2 to 3? I will use this one, the mole-to-mole ratio between X. What is the mole-to-mole ratio between H2 and O2? My X and Y here, H2 and O2. Which one is the X? It is the given, it is the H2. Which one is the Y? It is the O2. Which one you will put it in the top, which one go up at the bottom? It is very important. So here, I have the mole-to-mole ratio in the equation, 1 for the O2, 2 for the H2. So I will put 2 mole H2 in the bottom, 1 mole O2 in the top. Now, you can cancel mole H2 with the mole H2. Now, be careful. We need to keep going because we need to reach to step 4. Now, I'm in step 3. I'm here. I want to go to step 4. How you will go to step 4? By using the molar mass of Y. Which one is the Y? It is the O2, what they are asking. Okay, what is the molar mass? How you will write it down. Okay, this is the molar mass formula. Mole, 1 mole of X equal mass of X in gram unit. So here, I will put the mole O2, 32 gram, because it's O2. Be careful. So it will be 16 times 2, because we have 2 oxygen. So it will give you 32 gram O2. Now do the math after you cancel mole O2. 2 divided by 2 give you 1, and that will give you 32 gram O2. So this is the mass of O2 required to react with 2 mole H2. Okay. Now let's keep going. Practice with some other example for the same reaction. Let's say how many gram of H2O will it produce if 80 gram O2 was reacted. Okay, now we have the starting information or given information, sorry, 80 gram. First of all, look to the map, where you are. Are you on step 1 or 2? We have 80 gram, put 80 gram O2. Are you on step 1 or step 2? Mass, gram, so it will be in step 1. I'm in step 1. Now, where should I go? To step 3 or step 4? Look what they are asking. How many gram of H2O? So I will go from step 1 to step 4. First of all, you will go from 1 to 2 by using the molar mass of X. Then from 2 to 3 by using the mole-to-mole ratio. Then from 3 to 4 by using the molar mass of Y. So 80 gram of O2 times the molar mass of X to go from step 1 to step 2. It is 1 mole in the top and O2, so it will be 32 32 gram O2. Keep going. We need to go from step 2 to 3 by using the mole-to-mole ratio. What is the mole-to-mole ratio? Between O2 and H2O. What it is, you will get it from the balanced chemical equation. So here, I will put the 1 mole O2 because I have it 1. And the 2 mole H2O, you will put it here in the top. Cancel mole O2 with mole O2. And next, I will go from step 3 to step 4. We will go from step 3 to step 4 by using the molar mass of Y, which is the molar mass of water. Which one will go to the top? Which one you will put it in numerator? It is the gram. So here it will be 18 gram H2O divided by 1 mole H2O in the denominator. That's a mole H2O, mole H2O. Do the math, 8 divided by 32. And we have here 0.5. Just check the math, guys. As I said, I'm not using the calculator. So I think it will be 9 gram H2O. 9 gram of H2O. As I said, just double check the math. 8 divided by 32 times 2 divided by 1 times 18. So it will give you 90 gram H2O. And this is the answer for this question. Okay, so let's keep going and practice with more example. Okay, I will keep this map here. As I said, it's very important to use this map when you are dealing with this type of question. It will help you a lot. It will make the life easy for you guys when you are dealing with this type of question. Okay, so let's look for another reaction. Let's say we have let's say we have, for example, H2SO4 plus KOH give us K2SO4 plus H2O. Let's balance this chemical equation. So here we need to multiply this one by 2 and 2 H2O. Okay, now it's balanced. Okay, let's say we have this equation. How many mole of KOH will require to produce 1 mole K2SO4? Always start with the given information. What they give you? They give you 1 mole K2SO4. Now we need to know where we are, in step 1 or step 2 in the map. I have mole, so I'm in step 2. Look what they are asking. To know where you have to go to step 3 or 4. They're asking for mole of KOH, so I will go to step 3. I will go from 2 to 3. How you will go from step 2 to step 3? By using the mole-to-mole ratio between X and Y, which is here KOH and K2SO4. So here, just using the mole-to-mole ratio, which one will go to the top? Which one will go to the bottom? Here, K2SO4 will go to the bottom. How many mole of K2SO4? I have 1. It will be 1 mole K2SO4. And in the top, it will be the KOH. How many KOH I have in the balanced chemical equation? 2. It will be 2 mole KOH. That's a mole. This one, and that will give you 2 mole KOH. It is the answer for this question. Okay, now let's keep going and practice. Guys, I'm using some simple numbers, okay, to do the math quickly. Of course, maybe in the exam, in the homework, they give you just a little bit complicated number, like point with a decimal point, point 0.5 more, 0.001. So of course you will need maybe the calculator, but I'm using just simple number to go quickly with this equation. I'm not using the calculator. Okay, for the same reaction, let's say for example I have this equation. How many mole of H2O will produce if we have let's say for example here we have 9 56 gram KOH. Okay. First of all, let's start with the 56 gram KOH. Now, 56 gram KOH, they give you math. So where you are, step 1 or step 2 in the map? I'm in step 1. I need to know where should I go. They are asking for how many mole of H2O. That means I need to go to step 3. So I will go from step 1 to 2 by using the molar mass of X, then from 2 to 3 by using the mole to mole ratio. So here, 56 gram KOH times the molar mass of KOH. What is the molar mass? How you will write it down? Which one will go to the top? The mole or the gram? The mole will go to the top. 1 mole KOH. What is the mass for KOH? Potassium 39.9, I think approximately 56.9. Let's do it 56, okay? Just double check the mass of KOH, okay? Now, gram KOH, cancel by gram KOH. I'm in step 2 right now. I need to go to step 3, so I will use the mole-to-mole ratio between KOH and H2O. What is the mole-to-mole ratio between KOH and H2O? It is 2 to 2. So here, which one will go to the top? So it will be 2 mole H2O divided by 2 mole KOH. Cancel mole KOH with mole KOH. Do the math right now. 56 here, approximately 1. So it will give you 1 mole H2O. And this is the answer for our equation. Okay. So let's keep doing the practice with some more example also, just 1 or 2 more example with this reaction. Okay. How many grams of H2SO4 will be needed to produce 4 more H2O? Okay. Where we are, step 1 or step 2, I have 4 more H2O. 4 more H2O, so I'm in step 2. Where should I go? To step 3 or 4? They're asking for how many gram H2SO4, so I need to go to step 4. So here, we will go from step 2 to 3 by using the mole-to-mole ratio. What is the mole-to-mole ratio? It is between H2SO4 and H2O from the equation. This is the mole-to-mole ratio. Which one will go to the top? 1 mole H2SO4 to the top. Which one will go to the bottom? 2 mole H2O. So mole H2O with mole H2O. Now I need to go from step 3 to 4 by using the molar mass of Y, which is the molar mass of H2SO4 here. Let's calculate it. So it will be 1 mole H2SO4 here in the bottom, and in the top, so sulfur is oxygen here, 64, 32 for the sulfur plus 2, so it will be 98 gram H2SO4. Then some more H2SO4 with this one. Do the math here. 2 times 98 will be 196 gram. Also, just double check the math. No, sorry, not H2. It is H2SO4, 196 gram. Okay, guys. So hopefully that will help you with the stiocheometry. Always try to practice a lot. We have some example in the PowerPoint slides, and here also we have some example that I went through it. Okay, so I think we're done for the stiocheometry. Okay,